I'm Mark Kavanaugh for Kevy Coaches, and today I'm going to coach you up on recapping the sticky tape activity. In this series of videos, we're going to talk about electrostatics, fields, and electric potential. We're going to start with the sticky tape activity, and we're going to talk about positive, negative, and neutral objects. So let's go ahead and take a look at that activity first. All right, so here's the sticky tape activity. What we're going to do is we're going to take two pieces of tape that are stuck together on the table, peel them off the table, and then we're going to peel them apart. The piece of tape that was on top, we're going to label with a T, as you can see being hung there. And the piece of tape that was on the bottom, we're going to label with a B, as you can see being hung there. Then what we're going to do is we're going to do the same thing with another pair of tape. We'll rip them off the table and then separate them. And what we're going to do now is we're going to bring each of those objects close to the objects we have hanging there. So we have bottom tape, top tape, foil, and paper. The top tape you can see attracts the bottom tape. The top tape, close to the top tape, you can see they're pushing each other away. You can see this way that the top tape curls. As we bring the top tape close to the paper, it attracts the paper, and it also attracts the foil, but there's a little bit more attraction to the foil than there was to the paper. Now, if we bring the bottom tape close to the bottom, you can see they push each other away. The top and bottom attract, and we can see that the bottom tape attracts the paper, and it also has an attraction to the foil, but you can see it moved a little quicker, so it's a little more attractive to the foil. Now we're going to take the piece of paper and we're going to bring it close to all four. We know that it's going to attract both pieces of tape because that's what we saw previously. So it attracts the top tape and the bottom tape. But when we bring paper close to paper, nothing happens. Now the little movement there is just because they bumped each other. Same thing with the foil, nothing happens, but the little bump is what caused it to move. So there's nothing that happens. So now we're going to bring the foil close, and you can see the foil is a little more attractive to both pieces of tape. And then we bring the foil close to the paper, and we can see that there's no attraction to the paper, and there's likewise no attraction to the foil. Now what we're going to do is we're going to charge a piece of plastic, rubbing wool and a plastic ruler together. What this does is it transfers electrons from the wool to the piece of plastic, and it repels the bottom tape, attracts the top tape. We can see it attracts the paper, and it also attracts the foil. So the only thing it pushed away was the bottom tape. So let's go ahead and recap the sticky tape activity. So of the objects, which ones do we believe had a charge? Well, the tapes are the ones that had a charge, the top tape and the bottom tape. And the reason for that is they both showed attraction and repulsive behaviors, which is why we know that those have charges. And the neutral objects we know are the paper and the foil. And the reason for that is they attracted both objects, but they did not attract or repel each other. So they did not exert any repulsion with each other. So this brings us to the question, what does neutral really mean? So why were the neutral foil and the paper attracted to both pieces of tape? Does it mean that there's no charge? No, what it means is there's equal amount of charge for the paper and foil. So that's what makes them neutrals, that they have an equal amount of positive and negative charges. So when did the tapes become charged? So let's go ahead and look at two pieces of tape on top of each other. We've got a bottom piece and a top, and we rip part of them apart. Now the parts that are not ripped apart are neutral, so they both have equal positive and negative charges. But the parts that were ripped apart, the top tape lost electrons, which made it positive. We'll call that +2 since it lost 2 electrons. And the bottom piece of tape gained those 2 electrons, and that makes the bottom piece of tape a charge of -2 because it gained 2 electrons. So the tapes became charged after they were ripped apart, not during the ripping off of the table. And this is known as charging by friction, because the friction is what transferred those electrons from one tape to another. Now, why do the electrons transfer from the top tape to the bottom tape? So this is known as something as the triboelectric series. And this is just a ranking of materials and their tendency to gain or lose electrons when they are pulled apart or rubbed together. Here's the list of triboelectric series objects. Now, this is just some of the objects, and the further up it is on the list is more positive, and the further it moves down is negative. And the neutral object in the middle, cotton, this is why our clothes are made of cotton, because it doesn't hold charge very well. So we have less static in our clothing when it gets out of the dryer. Now, why did the tapes become charged the way they did? So let's look at the parts of the tape. See, the acrylic, which is the adhesive side of the tape, is listed here. And if we look further down on the list, the cellophane of the tape, which is the top part of the tape, is just below it on this list, which means the acrylic or the adhesive side is more likely to become positive and lose electrons than the cellophane part of the tape, which is the top side of the tape. It becomes more negative. So the sticky side was on top of the cellophane from the top to the bottom. So that's why the top becomes positively charged and the bottom becomes negatively charged, gaining those electrons. So let's answer the question that why the foil and paper attracted both of the tapes. So let's look at a piece of paper that is neutrally charged. It has equal amounts of positive and negative charge. So let's bring a piece of top tape close to it. We can see those electrons shift towards that piece of top tape. And this is a nonmetal, so the electrons stay within their atom. They just shift to cause it to become more attracted to the top tape. And the shifting of those electrons is called polarization, which causes the paper to attract the top tape. Now, if we look at that and we bring the negative piece of bottom tape, we can see that the electrons shift the other way, making the side closest to the bottom tape positively charged, so it attracts it as well. So it doesn't matter which piece of tape the paper is brought to, it's going to attract both. Now let's look at the foil. Now, foil's metal, and the electrons are going to move a little easier in the metal because of the structure of aluminum foil. And if we look at a piece of top tape being brought towards it, you can see that all of those electrons that are free to move are going to move all the way over to the side, which cause that foil to be attracted to the top tape. And this is also why the foil is more attracted to the pieces of tape than the paper was. Now, if we look at the bottom tape, the opposite happens. Those electrons push all the way to the other side, causing the surface to be positive closest to the bottom tape and also attracting. So that's why the paper and foil, our two neutral objects, are attracted to both tapes that have opposite charges. So let's recap our sticky tape activity. So with the pieces of tape, we know that they were charged when they're ripped apart, and the top tape became positively charged and the bottom became negatively charged. And that was charging by friction. And the tapes became charged based on the triboelectric series, where the top piece of tape, the sticky side, is further up than the top part of the bottom tape, which is further down on that triboelectric series, causing it to become more negative. And then the paper and foil, we know that those are both neutral objects, which means they have equal positive and negative charges, and they attract to both pieces of tape by polarization. The foil is more attracted because of its structure at the molecular level, causing the electrons to be able to move more freely. So that's why the foil attracted more than the paper did. So this is a recap of the sticky tape activity. I hope this was helpful, and I hope you have a great day and an even better tomorrow. If you found this video helpful, click the like button down below, subscribe to my channel, Cabby Coaches, and follow me on Instagram and X @CabbyCoaches.